we covered a lot of fundamental material in Chapter 2. So the more you can get the fundamentals of Chapter 2 sort of up in your head and not rely on a formula sheet, the better you're going to perform on quizzes and tests. And also the faster you're going to be able to get through your homework problems as well. So let's try to capture the main things that we covered in Chapter 2. We first talked about the energy contained in a system. In other words, the forms of energy contained in the system. And for this class, they consisted of internal energy, kinetic energy, and potential energy. Then we defined work and heat transfer. We defined work for a closed system undergoing a quasi-equilibrium process. And let's see, what was that? For closed system quasi-equilibrium process, that would be the integral work out equals the integral of PdV. If you got that up in your head. Let's see, heat transfer. We talked about heat transfer, and the way you can detect heat transfer is heat transfer only occurs between two systems that are in what they call thermal communication, and also the two systems are at different temperatures, where one of those systems is hotter than the other. We also identified that work and heat transfer are boundary phenomena. They're recognized when they cross the system boundary. So a closed system does not possess work. And just as important, a closed system does not possess heat. It certainly possesses internal energy, but it doesn't possess heat. Then we went on and then we combined all those those forms of energy, and we formed up the first law of thermodynamics for a closed system process. And there it is. I've written it out because it's so important. Q in, heat transfer in, minus the work out. Those are the two boundary phenomena on the left-hand side of the equation. Q in minus work out equals delta E, change in system energy, and that's made up of change in internal energy, change in kinetic energy, change in potential energy. Again, I just hope by now that you've maybe done some homework problems, you've gotten through that. I sure do hope that you've got that in your head, not just a formula. And then a special type of process is a cycle. That's where you start and end at exactly the same state. And showed how do you derive, or how would you calculate the net work done by a cycle, and that enabled us to then form up the first law, QH minus QL equals W net. So that's a simple, actionable statement of the first law for a cycle. It says the heat added minus the heat rejected equals the net work. How's your formula sheet coming along for either a quiz or an upcoming test? I hope that you recognize that your best formula sheet is your head. And I really want to encourage you to minimize if you're allowed to have a formula sheet, to really kind of minimize what you put down on that formula sheet. It's fine to write down reminders. If you're allowed, I think that's great. But the more fundamentals you can get in your head, not memorizing formulas, but the more fundamentals you can get into your head, the better off you're going to be in this class, and the better you're going to perform, and the better grade you're going to get. And I hope you get a good grade. Might want to check out my playlist called HW Solutions, Homework Solutions. And I've got 3 offerings here. One in problem 223 is a somewhat complex, I'd call it a moderate difficulty homework problem. You see my little hand-drawn sketch there. I work it out start to finish. And then I've got 2 problems where I've worked out the solution in MATLAB. Even though I've started with a sketch on pencil and paper, I've worked out the numerics in MATLAB just for students who might be interested in dabbling in MATLAB, in applying MATLAB work that they've already completed onto a subsequent class in ME. So you might just consider that, even though you would not be using MATLAB on a quiz or a test. How's your quiz and test preparation coming along? How's that coming along? So just as a reminder, similar to my reminder from chapter 1, the best way to maximize and get good performance, to show good performance on quizzes and tests is attending every class. Show up to every class. Participate in class. Ask questions. Get kind of brave and ask a question. If you need to, if you're confused by something your instructor or professor says or is going to a little too fast, respectfully speak up and say, "I'm a little confused about that. Could you say that again?" Or ask your question in a different way. And of course, the other part is keeping up with your homework. Really want to encourage you to keep up as your homework is assigned. Try to keep up with it. I know there's a lot of time constraints that you have, and you're taking a good number of classes. Really want to encourage you to do your best to keep up with your homework as it's assigned. Now, looking ahead to chapter 3, we're going to cover two categories of substances in chapter 3. The first thing is, how about H2O? Notice here that I wrote down H2O. What would you say the familiar name for H2O is? I didn't write it down for a reason, because H2O could be water, it could be steam, and it could be ice. And it could be some other things too, but basically those are the three that you know off the top of your head of what H2O is, and that would be a good example of a substance that can change its phase, but it's still H2O. So phase change substances, one category of substance, and then ideal gases, things that typically air, nitrogen, things, molecules that you recognize as a gas, we're going to describe those as ideal gases. Those are the two basic categories. And then once we get through that, we're going to do a lot of details about how to evaluate properties of various substances, properties of those two things, particularly, hey, specific volume. How would you calculate specific volume if you weren't given the volume and the mass? How do you quantify internal energy, U? We haven't said anything about that yet. How do you get a number for the value for U or little u? Now, you see, I've labeled that as hard. I would definitely suggest that that is some hard material that's going to require a lot of practice for you to do. And also, you're going to be assigned problems that put it all together. And so these problems in Chapter 3 get harder because you've got to read a problem, dissect a number of the details that are given. A lot of these problems are not the old step 1, step 2, step 3, step 4, and you're finished. Which chapter 1 problems were a lot like. So that's looking ahead towards chapter 3. So I hope you're getting some benefit out of watching these videos, and I'm going to go back to the drawing board and start creating presentations for chapter 3, and we'll create the videos as I can come up with them. Hope to see you then.